Hello everybody. In this video I will introduce you into Kalypso WSPM, which is a module of the Kalypso modeling platform. WSPM means Water Surface Profile Manager, and where we can make water surface calculation with that. I'll open it. Here I have my project explorer. At the beginning it's of course empty. If I want to start, I can start from scratch and create a new project. I can extract a demo project, or I can also import a project. This is what we'll do. I click on it, I left click, and I select an archive file. I browse to the zip file that is provided, say open, and here I have a project which is called Estuaries. Este is a river that we will work on. And I click on finish, and now my project is imported. Make a left click on it, and this is the GUI of Kalypso WSPM. I have here a project explorer. I have here an outline which is empty yet. I have my working view here, and I have a feature view and a console, which is already which is empty here at the beginning. So this is my project. It has some subfolders. One is data. It contains some data. In this case, this is shape data, and some images that we will need later. We have a DTM folder, which is called Digital Terrain Model. We have a terrain model inside. And we have a folder that is called Ergebnisse, which is German for results. And here the results, that the calculated results will be stored. I have a map here that we can use. We have a model file where all the model information is stored. And we have a WSPM GMV file. This is the file that we are working on. It is already opened here. I can close it, or if I close it, I can just make a double click on it and it will be reopened. So this file is organized in water body, calculation cases, and definitions. I will start on top. If I open water bodies, I have here already my river, which is called Este. I already created it, and it contains profiles, river strengths, discharge events, and water level fixations. I will open the profiles, and as we see here, we have a lot of profiles. They all have a kilometer, a station, and this is station 0, and it goes up to station 13.814, so nearly 14 kilometers of river we have here in profiles. Okay, we have also some additional information. In this case, we have the information that we have a gorging station, the gorge A, we have here, and in the upstream part we have the gorge D. So this is very important, since a model always needs boundary conditions, and it makes of course sense to extend the model from one gorging station to another gorging station. We have here also some other gorges in between that we can use, for example, for calibration purposes. So, for example, at this profile, we also have the information that this is a weir, and we also have some additional information. So here we have a picture of the weir, and we look from downstream to upstream and see the weir. The same for bridges. We have here some additional information. This is a normal profile. If we want, we can also add, if we have some information, we can add the URL of the picture here, and then we also can see the image. Okay, if I want to look at the profiles, I make a right click and I say display profile, and this is now I'm in the profile manager. Here I have all the profiles that I can click on, and every profile is stored in a table which has width, the height, easting, northing, and the KS value in this case. And here these are the attributes. Problems are an attribute, water levels, roughness, riverbed, and flow zones I have here, and they are visualized here in this view over here. I'll make it a little bit bigger that we can see it. So for example, the orange line here, this is the riverbed. I have it in the legend here. This is the height. I can switch it off and on if I want. I have here my flow zones. I have bankful points. I have divider, which are in German they are called the Trennflächen, and in English these are the interface zones that needs to be set by the modeler. They are already set in this model, and we have also a flown through area. This is the blue line here, and this is the area where the momentum balance is made. The roughness is here. I can switch it on and off. These are the gray boxes here, and there's already a roughness assigned, a pre-roughness is assigned, not the final roughness at the moment. So we have a KS value. We can choose here between KS values, or we can also say we can add a Manning's N. In this case, we will deal with roughness KS, and the predefined roughnesses are 0.3 meters at the flat planes, and in the river tube 0.15 meters. So here I could add in KST value. And if I change it, if I want to change it, I can of course change it here, but there are also some different possibilities that will be shown later on. So this is the view, and if, for example, if I want to add some attribute, I can use this green plus here, and for example, I could, to the profile, I could add a bridge, a weir, culvert, some vegetation. If I have trees, for example, I could add comments, codes, sinuosity, or also some energy loss. So I could, for example, let's say we add some sinuosity, then I see it here, and the new attribute, and this new attribute needs, of course, some parameters that needs to be defined by the user. If I want to remove an attribute, I can do it with the red X here. Okay, for example, in this case, we have a bridge added, so we have here the bridge, and the bridge has a lower edge and an upper edge, and that is visualized here. I can switch it on and off, so this is lower edge, this one, and this is the upper edge. And here I also have some vegetation, for example. So if I want to go back, I click on water level calculation, and I'm back here in the GUI of WSPM from the beginning. So these are all the profiles here that are part of the model. I'll make them smaller. Let's go to the river strings. In the river string, or in this container, here the profiles are organized. For example, if I want to make a subsection of my river, so I don't want to run my model on the whole 14 kilometers, but only the lower 2 kilometers, for example, then I can organize them, and I can organize them here in the river strings. So I can create a section. If I want, I make a right click, I say new river string, and now I can give it a name, and let's say subsection, and here I can add the profiles that I want. So let's say we wanted to have the 2 kilometers. I mark them. I say check selected, and now all of them are checked. And now my subsection contains only the profiles from kilometer 0 to kilometer 2.05. So I also predefined the whole section from Emmen, which is the gorge D. So Emmen is the name of a village near it, and it goes from Emmen to Buxtehude Harbor. So from kilometer 0 to kilometer 13.81. So, and as we see, we have here some discharged, or we have some gorges where discharge and water level is measured, so we need it as boundary conditions. We also have, of course, to define some discharge events if we want to run a model. This is already done here. I could add again by right-click and say discharge event, but I already created some. So here we have the mean discharge event and the flat discharge event, and then they are organized in that way that we give a station, and the station has a discharge. And we always look at the discharge which is in the river. So which means at the station 0, where the calculation starts, we have discharge of 2.5 cubic meters per second. At the station 9.21, we have a discharge of 2 cubic meters per second, which means that 0.5 kilometers are added somewhere in between of that. So we can see here it in the diagram view. And at the very upstream profile, we also have 2 cubic meters per second. For the flood discharge event, we have, of course, higher discharges here. Okay, water level fixations we don't have yet at the moment. Mostly we don't have water level fixations. Okay, now we looked at the water body ester, and now we can look at some calculation cases. So if we want to run our model, we need to create a calculation case. We can make also a right click on it, say new, and we can choose between polynomial processing and water level calculation. In our case, we want to make a water level calculation. And I already predefined some calculation cases, one for mean discharge and one for flood discharge. Okay, what we see here is we have a feature view of our calculation case, and where we have to add all the information. So, for example, a name, a description, who created by, let's say this is my name, Edgar created it, and the date, which is today, for example. What I'm I can set, and I can also give some descriptions like this is the status quo of the river, so no measures at all are done. I'll make it a little bit bigger. Now I have to choose a fluid model. I can choose between Darcy-Weisbach pipe flow equivalent sand roughness Ks, or Darcy-Weisbach open channel with profile impact equivalent sand roughness Ks. So we will choose this one. The theory is we had in the lecture of that. Or we could also use Gaukler-Manning-Strickler, so the KST value. And these are some settings. If we prefer roughness classes, so if we, for example, have shape data, then we can check them here. Calculation type, we can choose between water surface calculation, bank, full, steady uniform, or steady non-uniform discharge. We know the theory from the lecture. What we will do is we'll make a water surface calculation. And here I make a link to my section, Emmen Buxtehude Harbor. So this is the whole model that I want to run. And additionally, I have again to say where my calculation should start. So this is the very downstream profile, since we know that the direction of calculation is from downstream to upstream in this model. We know it from the manual. So we start at kilometer 0, which is here, and we end at kilometer 13.814. Then I have to add some discharge event. In this case, I choose the mean discharge event. And if we have, so this is the discharge event that I have here. And and we have and what we have, if we can add some water level fixation. Okay, so here we have no water level fixation. We go on with some initial conditions, some starting conditions, and we can choose between critical water depth, initial water depth, and steady uniform slope. In our case, we have a gorging station downstream, and here we can assign an initial water level, which has the value of 2 meters above sea level in our case. Here I choose a computational module, so there might be some difference. So they are, we have sometimes we get new versions. In our case, we choose the newest one. Some iteration theory, so how the basic equation is solved, some iteration method, some delay attrition, and some friction attrition. And here we can have some additional options, like if we want to include bridges into the calculation, and if we weirs. And of course, in our case, we have bridges and weirs, so we want to include them. And we could also choose another roughness approach if we have extreme roughnesses. Okay, so in this case, now this is all, and these two events are prepared, and if I want to run them, I can make a left click on it and then a right click and say start calculation. And here I'm asked for save, so there were some changes in the model, and I'm asked if I want to save. I say okay, and now my simulation starts, and here we see it, and after 4 seconds it's already finished. So 1D simulation is very fast. And now I can here go to my results, and here now a new folder is created with the name of my calculation case, and here I have a folder called Aktuell, so this is always the newest results, and here I have, this is the actual date and the time of my folder, and here I have the results. So here first I have, for example, I have a table, and here all the information is stored for every station. So for example, at this station we have the discharge, we have the soil level, we have the water level, so this was the predefined water level, and here we also have some velocity, shear stress, and many information we have here. So if I want to see them in a diagram, I make a double click on this Längsschnitt file, and here I see it in the longitudinal section or the length section. Here in my outline I can choose what I want to see and what I don't want to see. In the first step I only want to see the soil level, so the bottom elevation. Here I have my profile, my station 13.81, and it goes down until 0. So we have here some jumps, so we will see if we add, for example, bridges and weirs. So we see here we have a weir, 1, 2, 3, 4 weirs, and we have a lot of bridges here, especially in the city. We have some bridges. So, and my calculated water level I can add now, and this is the result of the calculation. So here I can see the water level, and for example I can also add the flow velocity here, and here this is the scale for the soil level, and here we have the scale for the flow velocity. I can also add, for example, the Froude number and some energy head, so the energy height can be added. I can add the discharge, whatever I want. So if I want to use the information, or I could use it for a report here, then I can make a screenshot out of it, or I can go to the table and say select all table rows, click on this button, left click, and then it's copied, and now I could, for example, paste it into Microsoft Excel or whatever. And then I can go, and then I can make my own diagrams and make, for example, some comparisons. Okay, so these were the table and the length section information. I don't want to save in this case. And they are organized in the maps, the results, for example. So here we have the map. We see here our profiles, and if we zoom in, we have here our flooded area. So we have here some information that can be switched on and off. So the inundation line and the profiles can be switched on and off. So of course it's always nice to have some maps in the background to see where we are. So for example, here I can say add a new layer, and here I can choose what I want to add. For example, a shapefile, GML file, some images, so if I have some background images, or for example I can add a web map service. So the web map service are freely available maps in the internet, for example OpenStreetMap, and some others. So if I have the address, I can type the address here, and then I can edit. So I already prepared one map, which is called STMap, so it is stored here. So I will close that automatically generated map and open this prepared map. Sorry, this was the wrong. This STMap. And here I already added a web map service in the background, so this is called Web Atlas. And here we have our model area, so the orange lines are the profiles. And we have a web map service, and I added also a legend, so a legend can be added here. Here, legend, I could also add a scale, for example, and say finish. And when I refresh it, I have a scale here, which is overlapping with the legend, which is not so nice. But let's work with the scale. Okay, here we have our profiles with the map in the background. And if I want to get my results now that I calculated to this map, I can also do it by this green plus, and I say I want to add a GML. So in a GML format, the results are stored. I say next. I browse to the GML file, which is in Ergebnisse, then my calculation, and I go here, data, and for example, I want to have the inundated area, and I say OK, click on it and say finish. And now I have here my model result in the map. It is called boundary, which is maybe not so nice. I can make a right click, go to properties, and here I can give it a name, and this is then, for example, inundated area for mean flow. And now I know what it is. If I want to change the color, I can mark it here and go to this color or to this style. And here then on the right side, here I can change the style. So let's say we want to make it yellow. Of course, water is not yellow, but here I can change it in that way. So this is how I can visualize it in the plan view, in the planner view, and the other possibility is to look at in the longitudinal section, which can be opened here. Okay, I would say that's it. Enough for the introduction for the first part, and yeah, see you in the next video.